All right, good morning. We're going to look at polynomial division. We're going to get started understanding a little bit about what polynomial division is and what it looks like. And this is section 5.2 from our textbook. Again, that's polynomial division. If you have any questions, please let me know in the chat. Just keep in mind there's about a 20-second delay from what I'm saying. So if I take a little while to get back to you, I will answer your questions, okay? All right, now I think the way to best explain polynomial division, well, we have two questions. First of all, we need to know why we even care about this. And then secondly, I'm going to use an illustration using real number division and show that how that mimics what polynomial division looks like, okay? So the first question, why? All right, so in section 5.1, we learn about how to graph factored polynomials. And if you know how a polynomial factors, finding its graph is actually pretty simple, pretty straightforward. So polynomial division, it's a more powerful tool to help us factor. In fact, it'll help us factor in ways that we haven't been able to do so far. Okay, so that's really why we want to do this. Now, let me give you an example of that. So if I said, let's divide 28 by 4. This is kind of what I would do in grade school. And let's think about how we do this. Okay, so how did you say 28 divided by 4? First of all, well, let's make it 29, okay? So we'd say, okay, well, 4 goes into 29 7 times, and then from there you'd write 28. And the reason you wrote 28 was why? That was 4 times 7, and then you subtracted to get 1, and that 1, again, was now 29 minus 28, okay? And that's how division works. I think that's familiar to us. And let me introduce some terminology here. So the 29 is what we call the dividend. That's what we're dividing into. The 4 is our divisor. That is the thing that's doing the dividing, is the divisor. The 1 is called the remainder. And the 7 is my quotient. This is the number of times my divisor can go into the dividend. All right, now another thing is you may not think about this a lot, but actually when I do division, for example, 4 goes into 29, we had a quotient of 7 and a remainder of 1. I could have rewritten this as 29 is the same thing as 4 times 7 plus 1 and verify that that's true. 4 times 7 is 28 plus 1, we get 29. And so what you can say here is that your dividend, which I'll call capital D, is the same thing as your little d divisor times your quotient plus r. All right, and so we'll use that with polynomials. And in fact, think about it. If your remainder was 0, you'd have actually factored it. Let's try another one real quick. Let's do 4 goes into, we started out with 28. Let's do that again. Let's go with 28. So 4 goes into 28. That's 7 times. And you get a remainder of 0. Okay, that means then that 28 is 4 times 7 plus a remainder of 0. We have factored it. And hopefully you can imagine now why we would be interested in polynomial division. Because when I divide, if I do division with a polynomial and get a remainder of 0, I have now helped factor that polynomial just like we did with real number division. Okay, now I see a comment that says what, but can you be a little bit more specific? And then I'll try to answer your question. Okay, so let's look at an example of dividing a polynomial. And I'm going to show you how the mechanics behind what we've done with real numbers applies to polynomials as well. Okay, so this is example 1. And here I'm going to divide x squared plus 2x minus 24 by x plus 6. Okay, I'm going to divide x squared plus 2x minus 24 by x plus 6. All right. Now the first thing we're going to do is write it just like we did the 4 divided by 28, or I mean 29 divided by 4, or 28 divided by 4. I'm going to write this x squared plus 2x minus 24. I'm going to divide all of that by x plus 6. All right, now over here, I'm going to write the example we did just now, 4 dividing into 29, to kind of help us remember what we did. All right, so we said 4 goes into 29 7 times. Okay, so the first thing we said was, how many times does 4 go into 29? Now, how do I do that with a polynomial? How do I do that with a polynomial? You have to ask yourself, what times x minus 6, or let's actually not even do x minus 6. Let's just start off with my leading coefficient in my little term here. What times x gives me x squared? And I'm looking at this term. So what times x gives me x squared? And hopefully we can see that that would be x. X times x gives me x squared. So I'm going to put an x up here. Okay, just like I put a 7 there. All right, this is the number of times x plus 6 goes into x squared plus 2x minus 24. Okay, now let's go back to our old school example. 4 went into 29 7 times. Then what do I say? 7 times 4 gives me 28, right? And that was, again, 7 times 4 gives me 28. So now what I need to do in my polynomial is I need to multiply everything here by x. Just like I multiplied 7 times 4, now I'm going to say x times x plus 6, which gives me x squared plus 6x. All right. Now what did we do? After that, we subtracted, right? We said 29 minus 28 gives me 1. And again, that was 29 minus 28. So now I'm going to subtract the x squared plus 6x. And what you need to be careful about here, and this is a very common mistake, is that you're subtracting everything. So what I recommend is you distribute your sign. That's a minus x squared, and I'm going to replace that plus with a minus 6x. That way I don't forget to distribute my negative. And when I do this, I have, let's see, x squared minus 6x, x squared minus x squared is 0. 2x minus 6x is minus 4x. And now I'm going to bring down the negative 24. And this is where this example is a little different than when we divide by 29 by 4. We need to do this again. Okay, we need to do the same process again to finish. Okay, so let's think back how we did this. Now I'm done with the x squared. I'm looking now at this term, the negative 4x minus 24. And I want to play the game again. So I need to think now, what times x gives me negative 4x? What times x gives me negative 4x? Negative 4x. Oh, I'm sorry. No, that's not true. Negative 4, right? Negative 4 times x is negative 4x. Okay, then what did I do? First I distributed the x across everything. Now I'm going to distribute the negative 4 across everything. So negative 4 times x is negative 4x. Negative 4 times 6 is a negative 24. And now what did I do again? I had to subtract. And when I'm subtracting, I want to flip my signs and add. And notice here, when I do that, I get 0. Okay. So what I'm saying here, and maybe I can make some notes on what I did. All right, so what did I do? First of all, that was the first part. What times x gives me x squared? And then 2, I distribute x among this term is my divisor, right? Okay, and that's how I got this. And then 3, I subtract. And then 4, do it again until I can't. All right, and so that's what I did here. That was number 4. I did it again. So again, you first ask what times x gives you x squared, or whatever the first term is. You take whatever that value is, you distribute it along your divisor, then you subtract, and then if you can, you run it again. You run it again until you can't any longer. And we couldn't because we had 0. We had to stop. Okay, now what this means here is we could say, so then we did our division. X squared plus 2x minus 24 is the same thing now as my quotient, my divisor times my quotient plus my remainder. My remainder was what? 0? Look at that. It's factored. We have now factored a polynomial in a new way. And this one we could have factored to begin with. I mean, what are two things? Multiply give me negative 24. Add to give me positive 2. How about positive 6 and negative 4? I'm sorry, negative 6, positive 6, negative 4, and we factored it. Okay? So we could have done this another way, but we're using this as an illustration to show that we can factor polynomials using division. Now, we don't always get 0 as a remainder, and that's okay. Let me go over another example, one that's a little bit more complicated to kind of illustrate that. So example 2, this time we want to divide, and I'm getting this example from the text, 6x to the 5th minus 5x to the 4th plus 10x cubed minus 15x squared minus 19. We want to factor all that by 2x squared minus x plus 3. Okay. All right. Man, that's a lot. Okay. We are going to just run the same thing again. So first we're going to write it 6x to the 5th minus 5x to the 4th plus 10x cubed minus 15x squared. I don't have an x term. There's no x term. So I'm going to put it in because it's going to help me keep my work in order. So I'm going to put in 0x minus 19. And again, I did that because it's going to help me keep my work lined up appropriately, kind of like columns. All right. And I'm dividing by 2x squared minus x plus 3. Again, what's the first thing we need to do? We need to figure out what times, what am I looking at? I'm looking at the 2x squared and the 6x to the 5th. And I'm saying, what times 2x squared gives me 6x to the 5th? Well, I know 2 times 3 is 6, so that part's taken care of. X squared times what is x to the 5th? And if you think about it for a second, x squared times x cubed. Now I can, when I multiply, I add the exponents, I get x to the 5th. Remember, when you multiply, you have to add your exponents together. So the answer to this, what times 2x squared gives me 6x to the 5th? I get 3x cubed. 3x cubed. That's my solution. That's what I think. All right. Now, once we did that, what do? We have to distribute this across all of that. All right. And when I do that, I get 3x cubed times 2x squared gives me 6x to the 5th. If you don't get 6x to the 5th, you did something wrong, because you're supposed to. That's exactly what you're supposed to get. 3x cubed times negative x gives me, let's see, negative 3, add the exponents, x to the 4th. And then I have plus 9x cubed, like that. And I'm subtracting, so I'm going to go ahead and flip all my signs. That's minus, plus, and minus. Add them together. I get 0x to the 5th, negative 2x to the 4th, plus x cubed. Bring it down, negative 15x squared, like that. And now I just have to play this game again. Let's run it again. Okay, so what do? I need to think what times 2x squared gives me negative 2x to the fourth? How about negative 1 times 2 gives me negative 2? And x squared times what gives me x to the fourth? How about x squared? X squared times x squared gives me, you add the exponents, x to the fourth. Alright, so when I distribute the negative x squared, I get negative 2x to the fourth plus x cubed. Alright, I'm distributing the negative x squared along here. So I get negative 2x to the fourth plus x cubed minus 3x squared. And now I'm going to, again, subtract. So I'm flipping all my signs. If you do that, it'll just help you avoid a silly arithmetic error that comes up every once in a while, okay? And now I add these together. So negative 2x to the fourth plus 2x to the fourth is 0. X cubed minus x cubed, well, that's actually 0 as well. And then negative 15x squared plus 3x squared, we get negative 12x squared. And I'm going to go ahead and bring down the 0x, and I'm going to go ahead and bring down the negative 19. And I think we can run it one more time. Alright, so let's run it one more time. Okay, now there is no one calculation here that's just overly difficult, but there are lots and lots of little boring calculations. And when you have lots and lots of little boring calculations, that means you have lots and lots of room for error. Okay, you have lots and lots of room for error. So, what times 2x squared gives me negative 12x squared? And the reason I said all that is we just have to be slow, meticulous, make sure we don't just skip over something. It's very easy to make a mistake. 2x squared times negative 12x squared, or times what gives me negative 12x squared? How about negative 6? I believe that works. We'll test it by distributing. So we distribute the negative 6 across here again. I get negative 12x squared. Okay, good. We did that right. Negative 6 times negative x gives me positive 6x. And then negative 6 times 3 gives me a negative 18. What's the next step? We subtract. So subtracting, I'm going to flip my signs. That way I avoid arithmetic errors. And when I do that, let's see, I get 0x squared. I get a negative 6x minus 1. Okay, now I'm saying that's the stopping point. And how would I possibly know? Because what polynomial times 2x squared gives me negative 6x? I can't go down in powers if I'm multiplying polynomials, okay? This is my stopping point. And let's make a note. I'll say this is my stopping point because the degree here is smaller than the degree of my divisor. Let's just say degree is too small. Okay, so I don't have a degree here that I have to worry about. Alright, now what is this telling me then? Well, it's telling me a couple of things. I could have written this in a couple of ways. First of all, I could say that this big polynomial, the 6x to the fifth minus 5x to the fourth plus 10x cubed minus 15x squared minus 19 equals this 2x squared minus x plus 3. That's my divisor times the quotient, which is 3x cubed minus x squared minus 6, which is complicated, right? But that's factoring that we could not do before, plus my remainder, which is the negative 6x minus 1. Now, if you want to identify your pieces there, again, I'm saying there's divisor times quotient plus remainder equals the big divisor. Okay? I hope that makes sense. Now, another way you could write this, let me go back up to my original examples here with, like, let's say the 4 divided by 29. Where did we write that out? Okay, we said we said here 29 is 4 times 7 plus 1. Another way I could have written that, and we just didn't here, is I could say 29 fourths, which is what we were trying to do. We were trying to divide 29 by 4, is the same as saying 7 plus 1 over 4, right? So all I did was take this equation and divide everything by 4. So 29/4 is the same as 7 1/4. Okay, and I could do the same thing. Sometimes it's helpful in the polynomial sense to say this big thing minus 5x to the fourth plus 10x cubed minus 15x squared minus 9. Divide all that by the thing that we were dividing by, which was my divisor, right? So this is what we were trying to find originally, dividing that by 2x squared minus x plus 3. Okay, that is the same thing as saying my quotient, which is the 3x cubed minus 6x squared minus 6, plus the remainder divided by the thing I was dividing by. Okay, and that may look more confusing to you, but that is another way of expressing what we just expressed. And all I'm doing is dividing both sides of my equation by the divisor. Okay? All right, now what I'm really interested in is, can you do this like example 2? And again, this is just a matter of memorizing the steps and being careful with your calculations. Okay? Great. Okay, I think we're going to stop it there for today. We're going to, next time, we're going to look at synthetic division, which is another version of polynomial division that's actually a lot faster. Okay, and synthetic division is very useful. Polynomial division is useful. I actually had to use polynomial division in my dissertation. Again, what does it help you do? It helps you factor big polynomials. And we didn't say this, but in this example, I know that 2x squared minus x plus 3 is not a factor of this huge fifth power polynomial. How do I know? Because my remainder was not 0, right? Just like 4 does not factor 29, it's not a factor of 29 because when you divide by 4, you get a remainder. Here I didn't get a remainder of 0, so I didn't factor the polynomial. All right, and synthetic division will help us do these calculations a lot faster, and we'll continue with that idea next time. If you have any questions, please let me know. Just keep working hard, and I just want to help. I hope you have a good day, and thanks for watching.